The second part of 7.3 Day 2 will include factoring. I wanted to quickly review the steps to solve as a refresher before we work on those final problems. When solving quadratic trig equations, the following methods are possible. You already have this, so let's just read through it quickly again before we start. If you have just a quadratic term, for example, cosine squared, but not a linear term, remember you just want to isolate that quadratic term and take the square root of each side. It sometimes takes a little work to simplify the other side that doesn't have the trig term, so make sure you're doing that. Always include the plus or minus in front because it's going to give you more possible answers. And then refer back to our rules in day 1 on how to find an angle and its second answer depending on if it's sine, cosine, or tangent. Today we're going to focus on problems like example 2 or part 2. When you have both a quadratic and a linear term, for example like a tangent squared and a tangent, what you want to do here is now put everything on one side because it's now a quadratic equation with that linear term, set it equal to 0, and then factor it. Once you've factored into your two sets of parentheses or whatever the option might be, set that equal to 0 and solve. Then we'll take the inverse and find all of our possible solutions like in day 1. In step 3, if by chance the quadratic is not factorable, you'd have to use the quadratic formula to figure out what you're going to take the inverse of. I think the problems that I give you are all factorable though, so we really hopefully don't have to worry about using this step 3. For these examples, it says solve for values of theta between 0 and 2 pi. So always recognizing the type of mode your calculator should be in or our answers should be in. This is now radian mode. Take a moment, grab your calculator and convert it if you need to, and then recognize the directions for rounding. It does say round to the nearest hundredth, so kind of follow that rule as well. Now for E, F, and G, we just want to decide, are we following the idea of step 1 or the idea of step 2? In example E, we have secant squared theta minus 1 equals 0. We just have a squared term. We don't have a linear term. What that means is we just want to isolate that squared term. To do that, I'm simply going to add 1 to the other side. And that leaves us with secant squared theta equals 1. I'm then going to take the square root of each side, and that cancels out on the left, leaving us with just secant. And then on the right, we have to do plus or minus, and the square root of 1 is 1. Now secant, remember, isn't one of the things that we'll evaluate. We want to use its reciprocal. The reciprocal of secant is cosine. And what's unique about the other side, when we take the reciprocal of 1, it's just going to stay 1. To get theta by itself, we'll now take the inverse. But we need to take the inverse of positive 1 and negative 1. Now 1 and negative 1 are actually on the unit circle. And remember, anytime we're on the unit circle, we have to have our exact values. So when does cosine equal positive 1, and when does it equal negative 1? Well, it equals positive 1 on the right at 0. And you could also say 2 pi, but then think about the directions again. Up at the top where it says our restrictions for theta, do you see how it's equal to 0, but it's not equal to that 2 pi on the right? Therefore, 2 pi, we're not going to repeat that location by saying 0 and 2 pi. We're just going to include 0 as our option. So that's something to consider as you're looking at writing out your solutions. It cannot equal 2 pi, but 0 is okay. All right, our other option then, when will cosine equal negative 1? Well, that's the x value, and it equals negative 1 on the left-hand side at pi. So 0 and pi are our only solutions for this problem. Example F is going to be our first factorable scenario. We have 14 cosine squared theta plus cosine theta minus 3 equals 0. Now we have a quadratic term and a linear term. To factor these, we kind of did this back in 7a, What I'm going to do instead of having cosines is I'm just going to replace them with x's. We'll keep our coefficient of 14. Instead of cosine squared, I'm going to write it as x squared. And then the cosine in the middle is just plain x, and then the constant is minus 3. If we think about factoring with that lead coefficient out in front, we're going to apply that earmuff method. Multiply the a and the c. 14 times negative 3 is negative 42. And now we have to figure out what numbers could we multiply to get negative 42, but then add to get positive 1 in the middle for that linear term. Well, lots of numbers go into 42. We have 2 and 21, 3 and 14. There's also 6 and 7. And 6 and 7, if we make one of them positive and one of them negative, we'll get negative 42 when we multiply. But in order to get positive 1 when we add, we need to make the 6 negative, and we'll keep the 7 positive. Now what we need to do is take the 3 terms in our equation and actually make 4 of them. I'm going to keep the first term as is. We're not going to change that at all. And then I'm going to split up that 1x in the middle to minus 6x plus 7x. Those two together would create that plus 1x up above. And then I'm going to make minus 3. From here, now that we have those 4 terms, group the first 2 and group the second 2. Now in that first parenthesis, 14x squared minus 6x, we could factor out a 2 and an x from both of them. If we take 2x out of 14x squared, we'd have 7x left over, minus, if we take 2x out of 6x, we'd have 3 left over. Now that second parenthesis is already 7x minus 3, and they don't have anything that could factor out that they have in common. But we need a placeholder. We have to have something in front. If nothing at all factors out, we're just going to put in a 1 as a placeholder. 1 times 7x minus 3 doesn't change anything. From here, we notice that we've got a matching parenthesis. That's one factor. And then we take the parts on the outside and add them together to create our second factor. Ooh, this is a lot of review from quadratics. This is factored completely. 7x minus 3 times 2x plus 1. But remember, this is actually equal to 0. If we take 7x minus 3 and set it equal to 0, we have to get x by itself. I'm going to add 3 and divide by 7. And we get x equals 3/7. If all we were doing was solving a quadratic equation with x squared, we'd be done here. But guess what? This is now using trig terms. So instead of x, we actually now have to substitute in cosine theta. But at least cosine theta here is by itself. Now to isolate theta, we do our rules from day 1. We're going to take the inverse. I know, who knew this would be so complex? You probably thought it was coming, I'm sure. So here you go. That's a 3/7. Let's fix that. Sorry, you guys. Okay. Now, 3/7 is not unit circle friendly. Make sure your calculator is in radian mode and type in cosine inverse of 3/7. When you do that, to the nearest hundredth, you should get approximately 1.13. That's one answer. The second answer then, we take 2 pi minus that. That's an or. There we go. Our second answer should be approximately 5.15. So there are 2 solutions for that first part. Let's go ahead and take a look at that second parenthesis because we're still not done with this problem. I know, these will take a while. We don't have too many to do today for our homework. All right, that second parenthesis, if we go over here and we set 2x plus 1 equal to 0, this will be easy to solve. Subtract 1 and divide by 2. and we get x equals negative 1/2. So just like the last time, instead of x equals, we have to actually plug in our trig term now. So this is going to be cosine theta equals negative 1/2. Anybody recognize anything about negative 1/2 by chance? That's on the unit circle. Oh boy, so many things to remember. It's not a bad idea to have that unit circle handy when you're solving these, just in case you see one of our familiar looking fractions. Take the inverse. And because these are unit circle friendly, these two have to be exact. There's a negative right there. I hope you guys can see that. Where on the unit circle does the x coordinate equal negative 1/2? You should be in quadrants 2 and 3, and negative 1/2 is kind of towards the top and towards the bottom, but not all the way to the top and bottom. We're going to be at 2 pi over 3 up at the top, and then 4 pi over 3 down at the bottom. So we have 4 answers for this equation. Our final example, 2 sine squared theta equals sine theta. Now in this problem, again, we have a quadratic and we have a linear term. So believe it or not, we have to actually move that sign over and set this equal to 0. I'm just going to do that by subtracting it. So we have 2 sine squared on the left, sine on the right. I'm going to subtract the sine on the right to move it over. And sine squared and sine are not actually like terms. One's quadratic, one's linear. That means it's going to stay a subtraction problem. Like example F, where I see sine squared, I'm going to make that x squared. And then where sine is, that's just going to be x. To solve this by factoring, notice we don't have the constant at the end. So we're not going to do like the a times c rule this time. There's no c to multiply by. If you look at both of these terms, they both have an x in common. That's called a common factor. If we take that x out, we'd have to look at what's left over. If we take x out of 2x squared, we would just have a 2x left over. Minus, if we take x out of itself, it kind of cancels out, but we need a placeholder. And that placeholder is 1. And if we set that equal to 0, we've already factored this equation. It's done for the factor part. We just need to solve. We've got that x on the outside, and we have 2x minus 1 on the inside. We have to set both of them equal to 0. For that x on the outside, if we set that equal to 0, it's already by itself. Now what we would do is we would substitute sine in its place. So instead of saying x equals 0, it's sine theta equals 0. And to get theta by itself, we'll take the inverse. And 0 is on the unit circle. Sine equals 0 at 2 possible locations, on the right side and the left side. On the right side, it would be 0, and on the left side, it is pi. Those are our 2 answers when sine theta equals 0. For that parenthesis, if we set 2x minus 1 equal to 0, we'll just move the 1 over and divide by 2. And we get x equals 1/2. Knowing that we're not just solving for x, we're using sine as our trig function. If we say sine theta equals 1/2, to get theta by itself, we'll take the inverse. And once again, this one's also unit circle friendly. Where does sine equal positive 1/2? Now this is our y coordinate. It would be on the left side and right side again, up in quadrants 1 and 2. On the right side, sine equals positive 1/2 at pi over 6. And then over at the left, it would be 5 pi over 6. So there's factoring. Take your time on these. Some of them you'll have exact unit circle answers, and then some of them will be approximate. If they are approximate, make sure you're rounding to the nearest hundredth if you're in radians.